Let's 74. We're going to look at another example of distance formula problems. Just a little bit different. I'll read it first. Elena could run 4 times as fast as her challenger. In fact, she could run 80 miles in 2 hours less than it took her challenger to run 28 miles. Sorry for the glare there. How fast could each of them run? How long could each of them run? So in this one, let's look at a couple things that it gives us first. It says that what these types of distance problems are is they actually give us the individual distance of both of them. So we have one person here, Atlanta, and so she could run 4 times as fast as her challenger. So these are the types of people that we have. These are the distances we have, Atlanta and challenger. It said she, referring to Atlanta, could run 80 miles in 2 hours less than yada, yada, yada. So she could run 80 miles. So what we are saying here is the distance that Atlanta ran is 80 miles. So we put that in the equation here. Distance of Atlanta is 80 miles, meaning rate of Atlanta times time of Atlanta equals 80. And it says, continuing on, so we got that little part. In 2 hours less than, it took her challenger to run 28 miles. So the challenger ran 28 miles for her distance. Rate and time of challenger equals 28. So we can cross that portion out. Now we can kind of reread and see what else we see. What else it gives us. Looking back at the first sentence, it says Atlanta could run 4 times as fast as her challenger. So if it's talking about fast, it's talking about speed, meaning rate. So we could say rate of Atlanta was 4 times what? Times the challenger. 4 times the rate of the challenger. So now we've done this portion. And then it says, in fact, she could run in 2 hours less than. So she referring to Atlanta. So the time of Atlanta is 2 hours less than that of the challenger. So minus 2 since it's less than the challenger. So that's all it gives us. So now we kind of figure out where we can plug in. Well, this works out nicely because we have a rate and time of Atlanta, the same variable there. So we can plug these in to this equation. Sorry for all the arrows. But rate of Atlanta is 4RC, so we plug in 4RC for RA. Time of Atlanta is TC minus 2. So we plug that in for TA. And that all equals 80. Then we solve 4RC times TC. That would be 4RC TC minus 8RC equals 80. You may be thinking, well, we have 2 variables. How can we solve? Well, we have 2 variables, but do we know what them combined or multiplied equal? Well, we actually do. RC and TC over here says those equal 28. So we plug in 28 for RC, TC. We write the equation. 4 times 28 is, I believe, 112. I'm going to move all this over here. So 112 for that minus 8RC equals 80. And now we're just solving. Get RC by itself, subtract 112. It's negative 32 equals negative 8RC. When you divide, you get 4 for RC. So the rate of the challenger is 4. And it wants to know how fast each of them could run and then how long. Well, let's finish the speeds off. We know the rate of the challenger is 4. So therefore, the rate of Atlanta would be 4 times 4 when we plug that in. So the rate of Atlanta is 16 miles per hour, put in variables. And then it wants to know how long. So we got the rates down. Now how long? Well, we just plug in from this point. So let's see, what do we know here? We can plug in, let's use RCTC. I don't know where that. Let's use RC, TC. We know RC is 4. So erase that, plug in 4. So when you divide, you get TC is 12. No, not 12, 7. I don't know where that came from. And then you solve for the other one. So if that 7 minus 2 would be 5. I just plug 7 in for TC, 7 minus 2. It's 5 equaling TA. That's 5 hours or whatever it was. So that's how you do these distance problems. Just plug them in and don't get stumped with 2 variables. Oftentimes you'll probably know what those end up being. So that is the end of lesson 74.